Welcome to Math 1400, Nunez Community College. This is section 2.3, which is solving trig equations. Solving trig equations. So in order to solve a trig equation, we have to be able to know that the answers we're looking for is going to be within that unit circle and the ordered pairs that are on the unit circle. We are going to also remember that we have restrictions with periods. So we have, for instance, the sine, cosine, secant, and cosecant all have periods of 0 to 2 pi, which means the whole entire unit circle. And when we have tangent and cotangent, their periods are between 0 and pi. Again, we're going to use that for when we're looking for those ordered pairs that we're going to solve for. So the first thing that it says is solve for sine x plus the square root of 2. Sine x plus the square root of 2 equals negative sine x. Well, just like in algebra, we need to zero rule what we have and then bring everything else away to solve for our variable, which is x. So the first thing I'm going to do is bring the sine x to the left, giving me 2 sine x plus the square root of 2 equals 0. Now I want to take everything else away because I'm trying to get the value of x, which is going to be our angle, and we're trying to get the sine of that angle. So I have 2 sine of x equals negative square root of 2. Divide by 2, and I get that sine of x equals negative square root of 2 over 2. Now I'm looking for, on our coordinate plane, or unit circle, where is the sine, which happens to be the y value of the ordered pair, where is the sine negative square root of 2 over 2? Well, I know that square root of 2 over 2 is a pi over 4 angle. And I also know that the sine is negative in the third and fourth quadrants. So I'm looking for the sine value here because this ordered pair is what? Negative square root of 2 over 2 and negative square root of 2 over 2. The sine being that one. And in the fourth quadrant, it's what? Square root of 2 over 2 and negative square root of 2 over 2. The sine being the y value. So I'm looking for this angle, which is a pi over 4 angle. So that's going to be what? 5 pi over 4. That's one of my answers. And I'm looking for this angle, which is all the way around, being 7 pi over 4, because it's in the fourth quadrant. So I have x equals 5 pi over 4, and x equals 7 pi over 4. That's for the domain, or the period, of sine. These are the answers. However, some questions ask for what's called a general solution. A general solution. So if they asked for a general solution, that just means, in general, how many times can we hit this number? Well, we can hit this number by going all the way around and then coming back to it. And going all the way around again and coming back to it. And so on and so on. Or we can hit this one by going the opposite way and coming to it. So the general solution just means this answer plus a number of times around. And we know that all the way around is 2 pi. So therefore, the general solution is going to be x equals 5 pi over 4 plus 2 pi, which is all the way around, times n. N being the number of times around. The number of times around. So it's 5 pi over 4 plus 2 pi n, and x equals 7 pi over 4 plus 2 pi n. And that's what they're going to do, is they're going to ask you to find a solution, and then they're going to ask you for the general solution. And they may even ask for, suppose n was specific numbers. If they did that, we would have to plug those numbers in for n and then solve. For instance, I'm going to erase this part here, and suppose they say that find the solutions given that n is equal to -1, n is equal to 0, n is equal to 1. We can keep on going, but suppose they're asking us this. I would take each one of these and I would say, okay, well, 5 pi over 4 plus 2 pi, n being -1, and that would be my answer. So it would be what? 2 pi, if I'm written it right, and it's over 4 would be 8 pi over 4. So -8 pi over 4 and 5 pi over 4 would be -3 pi over 4. And then if I did the same thing here, I'd have 5 pi over 4 plus 2 pi, n is 0, so it would go away. I would just have 5 pi over 4. And then for this one, I would have 5 pi over 4 plus 2 pi n, which is 1. So that would be 8/4 plus 5/4 would give me 13 pi over 4. So these would be the specific answers if we went n times around one way or the other. This is the most that they could possibly ask you for. More than likely, it's just going to be find the actual solutions between 0 and 2 pi. But if they do ask us for the general solution, remember we have to take them and add 2 pi n, being the number of times around for each one. And then if they specifically ask me to plug numbers in for n, I'm going to do each one. I would do the same exact thing for 7 pi over 4. I would add 2 pi n, which is 8 over 4, to each one of those to come up with more answers. So that's what we would do for each one of these, but let's look at solving. So the next one, example number 2, says that we want to solve if we have 3 tangent squared x minus 1 equals 0. 3 tangent squared x minus 1 equals 0. I'm going to erase this here because we're going to use another one. Okay? The first thing I'm seeing is tangent, and I know that tangent has only a period of 0 to pi. So instead of looking at the whole circle, I'm only looking from 0 to pi. I'm only looking in the first 2 quadrants. So I'm going to do the same thing I did with the last one. I'm going to isolate my x, so bring my 1 to the other side, divide by 3, and then take the square root, because this says squared. I want tangent x, not tangent squared x. So tangent x equals plus or minus the square root of 1 over the square root of 3. And the square root of 1 is 1. So plus or minus 1 over the square root of 3. So where does the tangent of x equal 1 over square root of 3? Well, let me break it down to the ordered pairs that we know. And being that tangent is what? Y over x. That means that this is my y value. And the bottom one is my x value. But 1 and square root of 3 is not familiar on the unit circle. However, if we look at 1 as being 1/2, and square root of 3 is square root of 3 over 2, those numbers do look familiar. And when I have the fraction over the fraction, these numbers cancel out. So it leaves me with 1 over the square root of 3. So I'm looking for the ordered pair where the x is square root of 3 over 2 and the y is 1/2. That angle that we have here with that ordered pair is going to be the angle here, square root of 3 over 2, 1/2, and the angle here, square root of 3 over 2, 1/2. But this time, the what? Square root of 3 over 2 is negative, because in the second quadrant, our x is negative. But that's okay, because it says plus or minus. This angle in the first quadrant is pi over 6, because the x value is the larger of the two. And in the second quadrant, this angle becomes 5 pi over 6. So my answers would be x equals pi over 6 and x equals 5 pi over 6. That would be my answers. Now, if they asked for the general solution would be pi over 6 plus, not 2 pi n, Tangent and cotangent is pi, so it would have to be pi n, and x equals 5 pi over 6 plus pi n. That would be my general solutions for the tangent, and it would be the same thing if it was cotangent. Again, if they asked us number-wise, we would put numbers in and we would add or subtract them like it asks and solve. Okay, suppose we have another example, example number 3. And example number 3, a different type, is going to look at factoring. Suppose I have cotangent of x times cosine squared of x, which equals 2 cotangent of x. All right, I'm going to erase this again because we're going to use another one. Okay, and what are we going to do? Well, we're going to bring this over and zero rule it. So I got cotangent of x times cosine squared of x minus 2 cotangent of x equals 0. Now I'm looking at it as I got two terms with both of them having a cotangent in it, so I'm going to factor out a cotangent. So I'm going to factor out cotangent of x, and I'm left with what? Cosine squared of x minus 2 equals 0. So now, both these things multiply together to give me 0, so either this one is 0, or this one is 0. Okay? So on the left, this first one, if the first one is 0, we know the cotangent of x equals 0. The cotangent is what? X over y. It's the x value over the y. Where does x over y equal 0? Well, it's 0 where x is 0 and y is 1. That would give me 0. So therefore, that happens here. When x is 0, y is 1. That gives me 0. So therefore, this is pi over 2. So this angle, cotangent x equals 0, x is pi over 2. And then we have the other one. So we got what? Cosine squared of x equals 2. Take the square root. Cosine of x equals the square root of 2. Well, square root of 2 is not one that's familiar to us when we're looking at the ordered pairs. That's because, if we recall, the range of the inverse cosine, if we decide that this is x equals cosine negative 1, the range is what? Between negative 1 and 1. Between negative 1 and 1. And the square root of 2 is approximately 1.4 blah, blah, blah. So therefore, it's not within the range, so this side does not exist. So the only one that exists is here. That's the only one that can be 0. So therefore, this is the only answer. And if we have the general solution, that would be pi over 2 plus, since it's the cotangent, it would be pi n. That would be the general solution, and that would be the solution. All right, now we have example number 4. And example number 4 asks just a little bit different. It's one that we may have to also factor, but not factor out like we did here. Factor more like we do when we have trinomials, because it is a trinomial. So I have 2 sine squared x, 2 sine squared x minus sine x minus 1. Minus sine x minus 1 equals 0. It's already 0 ruled for us. It is a trinomial, meaning 3 things, and it looks like it can be factored. And it can. This factors to the 2 binomials, which is going to be 2 sine x and sine x, because they multiply to give me 2 sine squared x. With a 1, I got a 1 and a 1, and it needs to be a negative, so therefore the outside is going to be negative, the inside is going to be positive, so that we have a sine x and a negative 2 sine x. That gives me a negative sine x when I FOIL it out. So therefore, this side is 0 or the other side is 0. So I got 2 sine of x plus 1 equals 0, or sine x minus 1 equals 0. For the left, if I bring everything to the other side, 2 sine of x equals negative 1. Sine of x equals negative 1/2. Sine of x equals negative 1/2. So if I come to this side and I look at where is the sine, which is the y value, negative 1/2, that means that our ordered pair is what? Square root of 3 over 2, negative 1/2. And here, square root of 3 over 2, negative, and negative 1/2. These two angles are going to be what? All the way around, which is going to be, my x is the large one, so that's what? 7 pi over 6? Yes. And then from here, all the way around into the fourth quadrant, and that becomes what? 11 pi over 6. So x equals 7 pi over 6. And x equals 11 pi over 6. And then finally, we also have the other side, and the other side is going to be sine of x equals 1. Sine of x equals 1 when what? When the y value is 1, the y value is 1 here, and this is going to be what? Pi over 2. So my answers are going to be x equals pi over 2, 7 pi over 6, and 11 pi over 6. That would be my answers to this particular equation. All right, well, that is all for the section, which is section 7.3, trig equations. I'll see you at the next one.